Welcome back. So, in the last snippet, we had looked at the first law for open system. So, currently we will have two small snippets with some kind of a review. So, I will just write down the first law for open systems again and discuss a few things, and similarly I will write down the first law again in another snippet and write down some more few things that you must notice. So, let me write down the first law again right now. So, this is the first law as we wrote it, and you realize that the inlet and exit plugs do not any longer exist here, and as the delta t goes to 0, this is also okay, their effect really should not no longer be taken. You will also notice that the q dot and w dot s were really applied for the closed system, but finally here they appear as applied to the open system. You also notice that this expression for Hi has come in after we added U and PV, and this is one of the main reasons that H is defined as it is always. In open system analysis, the addition of terms U and PV comes so often that there is a necessity for such a short form, and by far this is the place where you will find H used the most. In closed systems, normally you will find H being used whenever there is a constant pressure process, but in open systems the flow term will always show up, that is the work involving flow, and that is always coming up along with U, and hence the H term always comes. So, this is something that you must notice, that whenever we are analyzing open systems, the term H always comes in because of the flow work. Now, you also realize that this is a reasonably general form, but of course, this is for a simplified system. Whenever we have more exits and inlets, these terms can be added over the inlets and exits. If things are not uniform across an inlet and exit, then you can of course integrate it. Similarly, these terms are net q dot, and at different places there could be different q dot. You will have to sum all the q dots. Similarly, for w dot there may be different modes of work. You will have to separate this w dot s into all those components of work and so on. So, though this is a reasonably general equation, you should realize what should be done whenever you encounter different situations. One can also think of situations where the heat transfer is not important, and we will discuss that, in which case the q dot term will go off. Sometimes you will realize that the work transfer is not important, and hence the w dot s term will go off. Sometimes there is no inlet, sometimes there is no exit, and whenever there is no inlet, this entire term with m dot I disappears. Similarly, whenever there is no exit, this entire term with m dot E can disappear, and only the remaining terms can be there. Sometimes the energy in the control volume does not change, it is a steady state system, in which case the left hand side can be 0, and each of these terms or each of these situations will be encountered as we move along. So, these are some of the things that you must keep in mind as we move along. So, in the next snippet we will just discuss the small differences between how the expressions look like for the first law in a closed system and for the first law in an open system, and similarly the conservation of mass. Thank you.